So good day guys, it's Vicol and in this video we're doing a simple C program to compute the sum of a series. So the question will be in the description here, you can read the question out, and it's just a simple question that says write a C program to compute the series S is equals to 1 plus x power of 2 plus x power of 3 plus x power of 4 plus then the continuous sign down to x power of n. So what this question asks us is we should do a simple calculator that is going to do a calculation from 1 down to x, then the power of 1 plus x to the power of 2 plus x to the power of 3 plus x to the power of 4 down till this person specifies, okay, I want you to reach the power of n. So this is basically the simple thing I'm going to be doing here. So now if the person specifies here that okay, the person wants to calculate this series to the power of 10, so it means this calculator is going to run from, after adding 1 we have our x to the power of 1, x power of 2, x power of 3, x power of 4. Then if the n was to be 10, then here will be x power 5, then power 6, power 7, 8, 9, 10, and then the program stops. So with that alone, you know you're going to be needing a for loop, because a for loop is going to be, you're going to be using a loop which actually is more favorable to use a for loop. So with the for loop, you're going to be creating you're going to making this loop such a repetition that for as long as the number of the highest power that the person entered, which is n, has not reached, as long as the highest power of the person entered, has not reached, the calculator is going to keep doing these powers for n minus 1 until it reaches n itself and then terminates the program. So that's what we're going to be doing basically. And to start with, this might be a problem for you guys seeing this power like x to the power of 2. How do you come about solving x to the power of 2? So there's a library file called math.h, so you can include it here now with std #include less than maths.h, just like your stdio and your stdlib, which stands for the standard input output header file and the standard library header file. So this one we're going to be adding the math header file, so you can be able to use this function called power. So to use the power function, you're just going to say pow, then the first parameter is going to be the x itself, like what value of x, the base value, let's say 40. Then the next parameter is going to be the power you want to actually get that base value to. Okay, let's just use let's say 12 to the power of 2. I think this is 144. So now let's try to print. I just want to test this thing for you guys so you guys see how it goes. So let's print the value of this to the screen. Okay, let's call it calc. So I'm going to be saying int calc is equal to this. So now I'm saying calc is going to be equal to 12 to the power of 2 using the power function. So power function takes two parameters, don't forget, the base value, which is in the first parameter, and the power value, which is the second parameter. So this is basically going to be doing what, 12 to the power of 2. So now running this now is going to give us, as you can see, we have 144 in our screen, 144. So if I change this now to, let's say, 13 also to the power of 2, that's 169. And yeah, you can see also 169. So now you've gotten a way we are going to solve each and every one of this. So all we just need to do now is to create a loop that will iterate for as long as this n value is not reached. And when it reaches n value, it should calculate for n and then stop the program. So very quickly, let me comment this out. So now let's go. What I want to do first is we are not collecting, okay, we're going to collect the value here, yes, because we don't know, this n specifies that the computer does not know the highest amount of iteration it has to go. The person can choose to do x to the power of 5 as the highest. The person can choose to do x to the power of 10, can choose to do x to the power of 12. So first we want to tell the person to enter the highest number, so print f. So you specified, please enter you said enter the value for n. So we want to also collect the value using scanf %d, because this will be entering an integer data type, and let's store it in, let's just name our variable n also. let's name our variable n. So at the beginning I will declare int n. So now that we have n as the value, we have to do a for loop now. So for the first parameter is going to be the iterating constraint, which is I, int I equals, we are going to be starting with 2 for a reason, and that is because, as you can see here, the first value of the series is going to be 1. Then after we have this 1 as the value of the series, the next thing we're going to be having is what? X to the power of 1, x to the power of 2, and x to the power of 3. So for each and every value of n that's going to be put in, it is this pattern is going to follow. So it means we don't need to start our x from 0. We are going to be starting our, we don't need to start our I from 0. We're starting our I from 1, since this is how the series is going to look like. So int I equals 1 for as long as I is less than or equal to n, then I plus plus. So this is going to run as much time as n is not reached. N is reached, sorry. So starting at, so if the person inputted 5 for year, program is going to run the first iteration, I is less than 5, run the second one, making it 2 is less than 5, it will do I plus plus, I return to 3 is still less than 5, it will do I plus plus, I return to 4 is less than 5, it will do I plus plus, I return to 5. So 5 is now equal to 5, so it's going to still calculate it and still give us the result, and then to do I plus plus, but then 6 is not less than 5 and 6 is not equal to 5, so the program is going to jump out of this loop and then calculate what we told it to calculate. So that is also what we are going to be needing. That's our approach we're going to be needing here too. So now what I want to do first is, yes, I'm going to be having a variable that will be summing each and every one of the thing we're going to be doing here. So before we get into that, let's just do this calculation now. So now that we have the value for I, what I want to do is I want to store, let's say calc is going to be equal to, I want to solve this thing and store the value inside calc. So calc is going to be equal to, the power function of n comma I. Like I said, you should have known this already. You should have known the 2 input I should have put inside of this bracket, because I told you the first one is the base element, which is, this is x comma I. X comma I. And also we need to collect the value for x. Sorry, I totally forgot. So here too we need to collect the value for x, because we also don't know the value for x. So in case x is 2, I want to do to the power of 5. So we're having 1 plus 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 plus 2 raised to power 4 plus 2 raised to power 5. So that's what we want to do. So here also change this to enter the value for x and then store it in x. So let's declare x also as an integer here. So now we have gotten value for x. So this calculator variable is going to be calculating x to the power of I for each and every iteration. So now once you run this program for the first time, I is going to be 1. So let's say our x was 2, the person inputted 2 our x. So the first iteration, this calc variable is going to be equal to 2 to the power of 1, which is 2. So it will store the value as calc. So now it will do I plus plus, our I turns to 3. Turns to 2. So now I is 2 is less than 5, yes. This is now going to do, calc is now going to be equal to what? 2 to the power of 2, which is 4. Then it will do I plus plus again, I turns to 3. So now I is 3 is less than 5, yes. It's going to calculate this again and do what? 2 to the power of 3, which is 8. So then it will do I plus plus. I plus plus is going to make I turn to 4. So 4 is still less than 5. It's going to do this thing. This is 2 raised to power 5, which is going to be 16. Sorry, I'm kind of lost in this calculation, but I believe you are following. So it's going to do it on and on and on till it gets to 5, and then it's going to terminate after 5, because 6 or numbers are larger than that is not going to suit this condition. So now that we have this already, we want to, like I explained in the previous video I did, I talked on the GP calculator. If you're writing a for loop like this and you have a variable that is storing this kind of value, it's going to get replaced. It will be overwritten for as long as the condition is running. So just imagine now, okay, you have this, like variables they're just temporary storage of data. I've said it before. So now this is a temporary storage. You are declaring as calc, and you are telling it to store the value of 2 to the power of 1 as at the first instance. So fine, it's a temporary storage, it's holding the data for you as 2 to the power of 1. But once this for loop runs for the second iteration and I is now 2, and calc is now seeing that okay, power is now going to be equal to 2 to the power of 2, then it will take away the previous value it was holding, which is 2, and then replace it with this new calculation. So therefore calc is now going to be equal to 4. So now if this for loop again runs for the third iteration and I is now 3, calc will also see it as okay, fine, you're telling me now to put my value as 2 to the power of 3. Then calc will displace the former value of 4 and then changes its value to 8. So that is going to be how calc is going to do on and on until the last part of this iteration. So what we need to do now is, in order to avoid that kind of thing, as soon as calc gets its value for each and every iteration, we want to sum it and add it to a particular variable, just like we did in the GP calculator. Yeah. So we're going to be naming that one. Let's name it result. Let me declare here and also declare an integer. Let me declare its results. So what I want to do now is, let me just declare it on another line. Yes, int, because I want to initialize it at the same time. Int results, is equal to 0. Exactly. This is what I wanted to tell you before. So we want to declare our result initially as 1, and this is because if you see our series, the series is always starting at 1 plus what, the iteration, like the iterative elements. We're always going to be starting with 1, meaning x to the power of 0. I hope you are following. This is basically x to the power of 0, then plus x to the power of 1. Okay, we can just leave it like that. So let's just leave if you want, okay, that's what it's about it. You can as well replace this to x to the power of 0, because no matter how much number the person enters as x, even if the person enters 1000 as x, it is always going to be 1 for the first value. Then the second one is going to be x to the power of 1, then x power of 2, x power of 3. So you can do it like that. In that sense, you're going to need to just change this I starting from 1 to 0. So that way the program will always start from x to the power of 0, then x to the power of 1, 2, 3, 4, 5. Or you can just start your results variable to be equal to 1, and then once you come here now to the bottom to store every value of calc, like I said I'm going to be doing. So what I want to do now is, as calc now is going to be storing the first value, which is let's say 2 raised to power 0 now, which is going to be 1. I want to tell our calculator to store this value in result. So result is going to be equal to result plus calc. So you are going to be doing this if this is going to be 1. This calculation is going to be correct if this is 1, because if this I is starting at 1, it means your previous result value was 1. So at this point of the calculation, result is going to be equal to what? 1 plus whatever is here. But if you're not going to be using that approach, you can just change this int I to 0, and then your results variable starts from 0 here also. So what this is basically going to do is, once it calculates for the first iteration, which is 0, this will be what? Power is going to be x to the power of 0, which is definitely going to be 1, no matter the value of x. So once that is 1, result is going to be equal to what? Result, the previous value for result, which is at the top here, which is 0. So it will be 0 plus 1. So at the end of this first iteration of the line 20, the value for result is going to be 1. So then the program does I plus plus, changes I to the value of 1. So now when I is 1, 1 is still less than 5. It's still it's still satisfying this condition. So it's going to calculate this thing again. So calc is now going to be equal to 2 to the power of 1. Then calc is going to be 2. So now that calc is 2, result is now going to be we are telling now result that you should do what? Add the previous value of itself to calc. So the previous value of result was 1. So this line 20 is basically now going to be doing 1 plus 2. So now I was 1 in this second iteration. So it's going to do I plus plus. I return to 2. So now that I is 2, 2 is less than 5. Yes, it's still a correct condition. So calc is now going to replace itself again by saying what? 2 to the power of the new value of I, which is 2. That is 4. So result here is going to also do what? Add the previous value for result, which is 2 to 4. That will be 2 plus 4, which is 10. So that is basically how this is going to get implemented. So are we done? So after all this, after getting the results to add for as long as this condition is true and all, we now want to print it to the screen. Okay, let me say printf. We now to see that what the sum of the series equals then %d, and I'm going to be displaying result variable here. So this is basically what we are going to achieve. This is basically it. Let me take this comment off. So this is just the few lines of code we need for this. So I need to declare result as a variable. Okay, I've done it already. I've declared, okay, I've not declared calc, so let me do for calc here too. Yeah, just that. So let's try to run this program. I hope there's no error because I'm teaching and coding at the same time. So let's run this now. Okay. Oh, looks like there's an error. So its result equals this, and it's not meant to be any error at all. It's not meant to be any error. Let me try this again. Okay, yeah, I don't know why it was blank before. So enter the value for n. So let's just try to do something basic that we can use our head to calculate. So let's just do 3 and x to be 2. So now let's use our head to do something like this. So with the series calculation that I'm going to put in the description, you can just do it. Let's do it with value of n and x. So once n is 3, it means x is 2, n is 3. So I'm going to be starting from, oh god, I closed it already. Let me open it again. N was 3, x is 2. Okay, so we have this here. Okay, press any key to continue is y. Okay, so our value is 15. Now let's come and verify this for n is 3 and x is 2. So now if n is 3 and x is 2, come in. So now n equals 3 and x equals 2. So okay, let's verify this now, that this condition, what we did was actually true. So the series we're going to be starting from x to the power of 0. For n equals 3 now, we're going to be x power of 0 plus x to the power of 1 plus x to the power of 2 plus x to the power of 3. So because n is going to be 3, so this is the height we can go. So now let's calculate this and let's replace this x now by 2. So let me just copy this and paste here. So the computer actually did 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 and 2 to the power of 3. So now let's calculate this ahead. 2 to the power of 0 is 1 plus 2 to the power of 1 is 2, 2 to the power of 3 is 2, then 4, then 2 to the power of 3 is 8. So calculating 8 plus 2 plus 4 plus 1, 8 plus 4 plus 2 plus 1. 8 plus 2 is basically 10 and 4 plus 1 is 5. So 10 plus 5 is 15. And you can see with this, with just this, how many lines? With just this, like about 20 lines of code, removing these white spaces, you solved that particular question. So it's not difficult at all. Just understand the approach you need and you get it right. So let me take these white spaces off. Sorry. So as you can see, we only spent about like 20 lines of code just from here to here, which is everything we need. So now let's try for something larger, then you guys can confirm it in your head. So I'm just going to use this to play a bit. So enter the value for n. Let's go for 7 and let's do 3. So the answer I'm seeing here is 3280. I'm not going to be confirming this myself. Use your calculator to confirm the value for x as 3 and n should be 7. On your calculator, do for x to the power of 0 down to x to the power of 7. Meaning, do from 3 to the power of 0 and sum 3 to the power of 0 to 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, down to 3 to the power of 7. And if your answer is equal to 3280, then yeah, you can comment in the description. So you can comment on YouTube, so I would get to see that you followed to the end of the video. So that's all for today, and do well to subscribe, hit the like button so others can find it really useful, and yeah, share it to a friend that you think is in need. See you next time.